Hello everyone, in this video we are going to discuss the solution for partition label. So let's see how we can solve this problem. Okay, so coming to the question, we have a string. Okay, so we need to partition the given string in such a way that in the partition, whatever the characters are present does not exist beyond this partition. Okay, so let me rephrase it. I want to create a partition such that in the way that the character present in that partition does not go in another partition, meaning if A is coming in a partition, in this partition, suppose if A is present in this partition, then A should not come in this partition or in this partition. Okay, so this is what we are going to do in this question. Maybe you haven't able to understand what I mean by this, so let's do a dry run and try to understand what the meaning of the question is. So let's try to divide this string in that way. Okay, so we first have A here, so let's see where the A is present. A is here, A is here, A is here. Okay, so for A, this is the partition. Beyond this A, beyond this line, this partition, the A does not exist. You can clearly see in this part, in this region, the A does not exist. Okay, on A is only occurring on this partition now. Okay, now let's see for B. B was the next character. Let's use a different color. So B was here, B is also here, B is also here, and now for B, the partition is here. You can see beyond this blue line, B does not exist. B is not here, not here, not here. In this region, B is not present. Okay. Now let's see another character. Now we got C. C is present here, here, and we can't see the C anywhere. Now for C, you can say that C does not exist beyond this green line. C is not present in this region. Okay, so this could be the partition, this could be the partition, or this could be one partition. But you can clearly see if I draw a line here, you can see that A is present in this partition only, B is present only in this partition, and C is also present in this partition. These three characters that are present in the partition does not go beyond this partition. So that's what we need to do in this question. Okay, so let's create one partition. This is my first partition, so let's write it A B C, A B A, A B C, B A, C A. This is one partition. Okay, now let's see another partition. Can we make another partition? We have D here. Now we got D1 here, and we don't have any more D. Let's move on to next character. We got A, E, E here, E here. Let's use a different color. E here, E here, and E here. E does not go beyond this. Okay, now let's see. We have F. F is only present in this part. Now let's see. We got E. We have already done for E. Now we have G. G is only present here, and that's it. We got one more partition. You can clearly see that D is present, E is present, F is present, E and G, D, all the D are present in here, all the E are present in this partition, all the F and all the G are is present in this partition. So you can now see we have one more partition, D, E, F, E, G, D and E. Okay, now let's see, can we make another partition? H, we have H here, then we don't have H beyond this. Now we got I is present here. Okay, now let's see the J is here, and now we have K is only present here, L is also present here, and now if you look closely, H is only present in this partition, I is only present in this partition, J is present only in this partition, K and L are present only in this partition. So we have one more partition, H, I, J, H, K, L, I. Okay. Now see, the characters that are present in the partition does not exist in other partitions. Okay, if A is present in this partition, A won't be present in second partition or third partition. Let's name them. B is only present in first partition. It is present in second or third partition. C is also present in first partition but does not exist in second or third partition. You can see in second partition we have D, which is only existing in second partition, not in first or in third. We have E, which is only existing in second partition. We have F and G, which are only present in second partition. In third partition, we have H, I, J, K, L, and these letters are only present in the third partition only. They don't exist beyond this third partition. Okay, so this is how we are going to partition in this question. This is what the partition in this string into as many parts as possible, so that each character appear at most one part. So this was the meaning of the second line. Okay, so that's how we are going to divide our string in partitions. Okay, now what we need to do with this partition is we need to create a list of integer which should represent the size of these parts. So we have 3 parts. Now let's try to calculate their sizes. First, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So if we are creating a list, then the size of first partition is 9. Now let's calculate the size of second one. 1, 2, 3, 4, 5, 6, 7. Okay, so size of second partition is 7. Now for third one, 1, 2, 3, 4, 5, 6, 7. Maybe I have forgotten to write J here. Okay, and 8, right? So the size of third partition is 8. So this was my result that I need to return, right? Let's save it somewhere safe. Okay, so now you may have understood what we need to do in the question. Now you can take 5 or 10 minutes to try to solve this question by yourself. Okay, and if you want a hint, I can tell you that this question is very similar to max chunk question that you have already done, max chunk 1 max chunk of sorted array and max chunk of sorted array 2. That was the name of those questions. You may try to find some hints from them, because in that question we were doing the same thing. We were trying to create some partitions such that we are able to sort it very easily. So we are going to do the same thing here. If you have understood those questions, this question can be done very easily as well. So try to find the solution by yourself. Take 5 minutes and think about it. Even if you don't have answer yet, it will improve your thinking capabilities. So think. All right, so I think you may have thought about it, and maybe you have been able to solve the question by yourself. And even if you don't, I'm going to tell you the answers already. So first of all, let's try to write the indexes of each character. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, so I have the indexes of each character now. This 23 is representing J. Okay, 22, 22. So don't try to judge my handwriting, because I know it's very bad. All right, so now what we need to do is we need a hash map to store the maximum impact of the each character. Okay, now why we are storing the maximum impact of each character, or rather I should say why we are storing the maximum impact of these characters. Now I told you that A was present here, A was present here, A was present here, and here. Beyond this A, beyond this 8th index, A wasn't present. Okay, so if we are checking the if we are creating a partition in which the character should be present, but beyond this partition the character shouldn't exist, so we should know till how much uh, index characters existing, right? So that's why we are trying to find the maximum index till which a character can exist. You can clearly see that till 8 A can exist, and beyond 8 A can't exist. So this is one possible partition. B exists in these places, so beyond this B can't exist. Beyond 5 B can't exist, as here you can see C is present till 7. Beyond this 7 C can't exist. So this could be my possible partition. Okay, so how we are going to check this? First we need the maximum impact for these characters, or I should say the maximum index till which these characters can exist. If I have somewhere this data, I may be able to deduce some algorithm or idea to figure out how I can partition this entire string. Okay, so let's try to create a hash map, and we are going to store it in that. And why a hash map? Because I thought it will be better. Okay, even though if you want you can use a array list, but if you will try to use a array list, it will be very difficult to access them. Okay, in hash map, if you know the character, you can access them very easily. So that's why I'm using hash map here. If you want, you can use array also. Okay, so let's try to traverse this this string one by one and try to fill the hash map with the characters and their maximum impact. So let's start from 0 index. So at 0 index I got A. Till now it is present in 0. Okay, now I move forward. I found B. I found at index 1. Now I have found A again. Now I I have moved till this second index, so I know that A could be present till second index. I haven't seen entire string yet, so I can just say that could be present till second index and B could exist till 1. Okay, when I have traversed and my entire array, then only I can tell till what point A can exist, till what point B can exist. Okay, now again I move forward. At index 3 I found B, so now I can say that B can exist till third index. Beyond that I don't know till now. Okay, now I move forward. At index 4 I found C at index 4. Now I move forward. I found B at index 5. So now B can exist till 5. I don't know if it can exist beyond that or not. Now I move to index 6. Now A can exist till 6. Okay, now again move forward. We have C. C can exist till 7 now. Now we have 8 index and we have 8. So we are going to update. Now I can definitely say that at the 8 index A could be present. Okay, now I move forward again. I found D at index 9. D at index 9. Move forward. I found E at index 10. Move forward again. I found F at index 11. Move forward. At E I found at index 12. At 13 index I found G. Let's start it here. At index 13 I found D at 14 index. Okay, now I found E again at 15 index. Now I'm at 16 index. I found H. Now move forward. At index 17 I found I. At 18 index I found J. I move forward. At index 19 I found H. So now I can say that till 19 I can found H. At index 20 I found K. At index index 21 I found L. At index 22 I found I. At index 23 I found J. So that's it. For each of the characters I have found the position till which they can exist. Now I'm going to use this information so that I can create a solution. Alright, so let's store it here. This is my hash map. Okay, so this is my hash map, and for each of the characters I have the index till which these character can exist in my string. Now I know this information, and from this information I can actually create partitions for my string. And how I'm going to do this? By calculating the maximum impact and the previous impact. Okay, so what I'm going to do is I'm going to travel from my entire string, and what I'm going to do is I'm going to see if my maximum impact that I have got till now is greater than my current character's maximum impact or not, and how I'm going to do and what I'm going to do by that. When I will do that, you will definitely know it. Okay, so let's create a previous variable. Let's make it here, and let's start it with -1 and maximum impact till now. Okay, let's move from here. At index 0, my maximum, I was initializing it with 0, so maximum impact of A is 8, so maximum impact will change to 8. Now B's maximum impact is 5, so max is still greater, so it won't change. Now we have found A again, maximum impact won't change. B again, maximum impact for B was 5, so it won't change. Now I got C, maximum impact for C was 7, so it won't change. I got B again, and we have 5 for the maximum impact of B. Max won't change. Now I got A again. A's maximum impact was 8, so it won't change. I got C, whose maximum impact was 7, which means that beyond 7, C can't exist. And now I reached A again. Okay, and the maximum impact was 8. Now, interesting thing is going to happen here, and that is that I have found my first partition. When the current index is equal to my current index I is equal to the maximum impact of the character that I have got till now. It means that I have found one partition. Okay, so I have found one partition, and what I need to do was calculate the size of the partition and store it in a string. Oh, sorry, not string, in an array. Okay, so I have a maximum impact of the character, which has now become 2 index, which means that there can't be there can be a partition in here. Okay, you can see B's maximum impact was till 5. Okay, C's maximum impact was till this point, and maximum impact for A was this, and we have reached a point at which the current index is equal to the maximum index. So it means now the partition of this maximum can't go further, and there should be a partition present here. Okay, so here we are going to create a partition, and we are just going to create a size in this condition. And how I'm going to calculate the size? It's very simple. I will just say maximum impact minus previous impact. Okay, so this previous means the previous impact of the previous impact of the last partition that I have got. Okay, and I have initialized it with -1 because I was using 0 based indexing for the string. Okay, if I will write max minus previous, it will be 8 minus 1 minus 1, so it will be equal to 9. Okay, Let's create res array also. So my first answer will be 9. So I stored 9. Now I have to update my previous, because now the max impact of previous has changed, because now last partition has become this partition and its impact was still 8. Okay, so that's it. It was 8. Now I move to 9 position. I got D here. D's maximum impact was still 14, so it will change to 14. Okay, now I move to 10 index and I found E. E's maximum impact was still 15, so maximum impact will change. Now I move to F. F's maximum impact was still 11, and maximum impact of the characters till now is 15, so it won't change. Now I found E again. Max impact won't change. G's max impact is 13, so it won't change. Now found D. D's max impact was still 14, it won't change. I found E at index 15. Now this condition is fulfilled, which means I found one more partition. So I'm going to create a partition here. So this will be my other partition. Okay, so same thing, maximum is now 15. Minus 8, which is nothing but 7. Okay, now previous is going to change to 15, because 15 has now become the previous maximum impact. Okay, now I found H's maximum impact is till 19. I found I's maximum impact was still 22, so it will change to 22. I found J's maximum impact is still 23, it will change to 23. I found H's maximum impact was still 19, it won't change, maximum impact 23. I found K's maximum impact was still 20, it won't change. L's maximum impact was still 21, it won't change. I's maximum impact was still 22, it won't change. And now I have reached the index 23, which is this condition. My current index is equal to the maximum impact, which means I have found one more partition. So I need to calculate the size. 23 minus 15, which is nothing but 8. And now we have reached the end of string. And now my loop will terminate. And I have found a resultant array which has 973, which is same as this that we have got by doing logical calculations. You can simply see here, here and here partitions were made. First partition, second partition, and third partition. Okay, so that's it for the approach, and you can clearly see first we needed was a hash map, and then we were just trying to calculate the maximum impact of the current characters. If the maximum impact of the characters was become equal to the current index, which means that we have found one partition. Okay, so let's code this and we will try to discuss what is happening in the code. Okay, so let's do that. All right, then let's code this now. So first thing what we need is a hash map. So let's create a hash map then. And this hash map should be of char and int. because char is going to contain the character of the string. Okay, and int is going to contain my maximum impact of that character in that string. Okay, so let's create that hash map, and we are done. Now we need to fill the hash map with all the characters and their maximum impacts. So let's do that. Int I equal to 0, I less than s dot length. Okay, I plus plus, and you just need to fill this hash map with the characters and their maximum impact. And what we mean by maximum impact, we mean that beyond that index the character does not exist. That is the maximum impact. Okay, so let's do that. First we need character from that string, so char ch equals s I, and we just need to put it in hash map and update our impact with I, because I was representing the index at which the maximum impact is present. Okay, now we have a filled hash map. Now we just need to calculate the size of the partitions. So for that, what we need was a previous, which was containing the index of the element, index of the last partition at which the partition was ending. Okay, and max, which was storing my maximum impact till now. Okay, maximum impact of the characters that I have got. So same thing, int I equal to 0, I less than s dot length, I plus plus, and that's it. We need a character, char ch equals s of I, and we just need to check if max. Okay, we need to change it to mx because otherwise it's going to give me error. Max is max of mx and the value of the maximum impact of the character. Okay, if the character's impact is more than my current maximum impact, then we should update the maximum impact. So we did that, and if somehow maximum impact become equals to my current index, this means that we have found one partition. So we need to calculate size first. Size was calculated as max impact minus previous, and we need to store it in the array, and we don't have an array, so let's make it vector of int. Let's name it result. That's it. Now let's dot pushback size, and that's it. And we need to update our previous with max mx, and that's it. Now we just need to return the resultant vector or array list. No, not array list, array. Okay, return res, and that's it. Let's run it now. Okay, it is showing some mistake at 13, I equal to 0, I less than s dot. Okay, braces was missing, and we have successful submission for sample test case. Let's submit for all test cases. And that's it. We got full marks, which means that our solution was complete and accurate. Okay, so in this question we just need to do three things to solve the problem. First thing, we need a hash map, and we need to fill the hash map with character of the string as the key, and uh, with their maximum impact values. And maximum impact value was nothing but the index till which that character can exist. Okay, beyond that index the character won't exist at all. That was the maximum impact for the character. Okay, second thing what we did was just go over the string once again and try to create the partitions. And how we created that partition? By calculating some max partition value. Okay, and how we did that was we just tried to see if the current index is equal to maximum index, then maximum impact, then it means that we have found a partition. And if we found partition, we just need to create we just need to calculate the size of that partition by subtracting previous from the max impact that we have got till now. And that's it. After that we need to uh, add our size to the array, and then what we need to do was just need to update our previous maximum impact. Okay, so that was only 3 steps problem. So I hope that you have understood this problem and its solution, and if you haven't, then I will request you to watch this video once again, and I'm sure that you will be able to understand it. Okay, if you are stuck somewhere, please see its Darren, because Darren will make you make the solution for this problem very clear. Okay, so that's all for the solution of this question, and I will see you in the next video with a new question. And till then, goodbye.